Good morning. Sorry about that. There were some technical difficulties when I recorded the last time, so it didn't quite go as planned. But here we go. You guys can now see the lesson that you missed from 3.3.21. Okay, so this is Wednesday's lesson. So this first section, it asks us, how do we find the minimum and maximum value of a function? Okay, so in order to do this, we have 3 examples of functions here. We need to start. Step 1, we need to find our midline. Now, the midline is what goes through the middle of our function. So hopefully you know it's going to be a horizontal line. It goes through your function, and this midline can be represented on a standard, like y equals sine of x. It's just going to be through at the x-axis because it has a midline at y equals 0. So as it shifts up or down, that will change the midline. If we look at this first one, the midline would be 2. Okay. Now, the second step, we want to also find our amplitude. So if we find the amplitude, for example, in this first one, the amplitude is 9. That's the distance above and below the midline it goes. So it goes 9 above the midline and 9 below the midline. Now, if we think about it, if we have a midline and some sort of function, right, like this, if that midline is 2, you know it's 9 above, 9 below. All we have to do is add and subtract. Okay, so we will, step 3, we add or subtract the amplitude from the midline. Kind of ran out of room here, but the amplitude from the midline. All right, I'm going to make this a little bigger just so it's easier for me to see, hopefully easier for you to see. But we'll add or subtract the amplitude from the midline. Okay, so now we look at this first one. We need to find our min and our max. We know that the midline is 2. The amplitude is 9, which means it goes 9 above 2. That would give us 11. It goes 9 below 2, so 2 minus 9, that gives us -7. Now in the second one, we also need to find the min and the max. On this one, the midline is at -5. Now, lots of you are going to be tempted to say the amplitude is -2. Technically, amplitude is our distance, so the amplitude is 2. This negative sign means it flips. It really won't matter if you use -2 instead, because it'll take care of itself when you go both ways. But instead, if we have -5 and we subtract 2, that gives us -7. If we have -5 and we add 2, that will give us -3. Okay, so those would be our answers. Now this final one, for our minimum and a maximum, first we find our midline. So midline is 12. 12 plus 11 says 23. That's our max. 12 minus 11, that gives us 1. That's our min. All right. So this first part, you guys had to do some questions like this on the Delta Math assignment. If you didn't get that done, take a look. It's not that hard. I think you can do it probably in about 5 minutes, but make sure you do it at some point. Now, today we're also going to talk about the cosine graph. Okay, so our standard graph is kind of like y equals just cosine of x. And for this, if you pull out your orange sheet, or we can look over here, right? And here's our unit circle. Okay, it looks a little different than the one we have, but it's the same unit circle. Now at 0 radians, what is the cosine? And the cosine is 1. Okay, so if we look here at 0, the cosine was 1. Now at pi over 2, that's up here, cosine is 0. At pi radians, over here, the cosine is -1. At 3 pi over 2 radians, it's down here, that's going to be a 0. And finally, 2 pi radians, we should know it's going to be 1 because it's the same as what we started with. But if you're not sure, remember 1 complete lap is 2 pi, so that would be 1. And that completes a period. Now, when we graph this, once again, the reason we chose those points, They are nice points. If I ask you guys to graph 1, 0, -1, 0, and 1, you will all have the same points. If I asked you guys to graph square root of 2 over 2, some of you would be higher, some of you would be lower. It's more of an estimation. Okay, so these are nice points, and then we draw the rest of it in. So we plot these points. 0, 1, pi over 2 is 0. Pi is at -1. 3 pi over 2 is at 0. And then finally 2 pi is at 1. Now, when we draw them, it'd be tempting to just draw a V right here. It's not a V. Remember, it's a sine wave, it's a cosine wave, so it curves towards the x-axis, okay? Now, if we wanted to, remember this would keep going. This is just one period of the cosine wave. It keeps going in both directions, up and down, or in this case, up and down, okay? So what changes can happen in a cosine graph? Much like yesterday, it's the exact same changes. So our formula, y equals a cosine bx minus d plus c, okay? And amplitude, the distance above and below the midline, okay, that is your a. Okay, your period is always 2 pi divided by b, with b being right in front of the x. Now your phase shift, so we'll determine if it moves left or right, and this is always d divided by b. Finally, your vertical shift, how much up or down it goes, and that is just going to be c. So today, now, we're just going to graph 3 of these, okay, 3 examples. Now, whenever we're doing this, in my opinion, it's nice to just list our 4 things and decide what is going on. So we have our amplitude, our period, there's a phase shift, and is there a vertical shift? And we want to decide what is happening. So we look over here, the amplitude is in front of the cosine. There's nothing there, which means it's a 1. Okay, your period is always 2 pi divided by b. In this case, b, whatever's in front of the x, is also 1. So 2 pi divided by 1 is 2 pi. If there was a phase shift, there would have to be parentheses, so we don't have a phase shift. The vertical shift is plus 2, or you might write up to, whatever you prefer. Okay. Now, you always take the period and divide it by 4. So 2 pi divided by 4, this will give us pi over 2. That is our interval that we're going to have. So when I graph this, I draw my line. Now keep in mind it's up to, so instead of being centered around 0, up to our midline is going to be at 2. Okay. Now, amplitude is 1, so we'll go 1 up and 1 below that. Now I also need to put those intervals on, so 1, 2, 3, 4. Okay, the first one we said was pi over 2. We found this over here. Pi over 2, that was our first interval. Now if we add pi over 2 plus pi over 2, gives us 2 pi over 2, which reduces to just pi. If we add pi over 2 again, we'll get 3 pi over 2. If we add it again, we'll get 4 pi over 2, which gives us 2 pi. Now hopefully it makes sense. The last one there, that last term, that should match up with your period. Okay. So now we need to plot these. Remember, we can always follow this pattern: 1, 0, -1, 0, 1. However, it's not 1 above the x-axis. It's not like just the one value always. It's 1 above the midline. So if we think about it, for this one, it will be at 3, 1 above. Now the 0 will be on the midline. The -1 will be 1 below the midline. 0 is on the midline, and 1 is 1 above the midline. Then we draw in the curve, and it might not be perfect, but there we have it. I think I drew that a little crooked, as you can see. Now, we're moving on to example 2. This one we want to do the same way. Okay, so we started off. Let's write down our 4 pieces of information. So amplitude, then we have is there a phase shift? Is there a vertical shift? Is there what is the period? Now on this one, the amplitude, we got to be careful. Some of you might be tempted to say -3. It is actually just 3. That's our amplitude. Oops, I put an M, so amplitude. The negative causes it to flip. So the amplitude is just 3. The negative will cause it to flip. Now our period is always 2 pi divided by whatever the b value is. In this case, 2 pi divided by 1/2. Now, as I did this, lots of people have had trouble. 2 pi divided by 1/2, they're tempted to say it's pi. That's not true. Half of 2 pi would be pi. But 2 pi divided by half, think about it, if we have $2 and we want it, or something costs 50 cents, so that's half a dollar. If we have $2, how many of that object can we buy? It'd be 4. So the other option, if you think about it over here, 2 pi, if we divide by 1/2, that's the same as 2 pi times the reciprocal, which is 2 over 1. That gives us 4 pi. Okay? Now, there's no phase shift because there's no parentheses and there's nothing trailing, so no vertical shift. Now remember, we always take whatever our period is. So in this case, 4 pi. We always take that and divide it by 4 every single time. So our interval is pi. Now we draw in our line. We draw 4 marks for our 4 intervals. This one, it's the first interval is pi. We add another pi, so 2 pi. Then 3 pi. And we add another pi, so we get to 4 pi. And as you can see here, we have our 4 pi. That matches our period, so we're good. Now the amplitude's 3, so we know we'll go both 3 above and 3 below the midline. Okay, so now all we have to do is plot it. Now once again, we take that 1, 0, -1, 0, 1, except we have to multiply those by whatever's out front. And even though that, there's 2 ways to think about it. You can multiply by the amplitude and then flip it down, or you can just multiply by -3. So 1 times -3, we'll start down here at -3. 0 times -3 stays at 0. -1 times -3 becomes +3. 0 stays at 0. And 1, once again, is down here at -3. And we draw that in. Oops, that's not my best drawing, but it will do. And we are done. Now we've got one more. Once again, this is just one period. It keeps going. It would keep going up and down and up and down. This is one period of this graph, okay? One cycle. So our final one. Once again, started off, we've got to find the amplitude, the period. Does it have a vertical shift? Is it a phase shift? Okay, so the amplitude, whatever's in front of cosine, that would be 2. Now, it's always 2 pi divided by b. In this case, b, whatever is in front of the x, there's a parenthesis, but there's no number, so it's a 1. 2 pi divided by 1 is still 2 pi. Now our phase shift, this is what's in the parenthesis, d divided by b, right? So we have pi over 1. So pi, now it's negative, which means it will be right by radians, okay? And finally, the +2 at the end tells us it's a vertical shift, +2 or up 2. Now, once again, to find our interval, we take 2 pi, whatever the period is, divided by 4. That will give us pi over 2. Okay? So now, we draw this in. It's up 2. So our midline is here. And the amplitude is 2. So we know it goes 2 higher, 2 lower. So we'll go all the way up to 4. And it will go as low as 0. Now I need to draw in 1, 2, 3, 4. So my over here, my interval, pi over 2, plus another would give us pi, plus another would give us 3 pi over 2, plus another would give us 2 pi. Now here's the problem. We know this one shifts right pi radians, so we need to go one more set. Okay, so that'd be 5 pi over 2 3 pi because we are going to shift it over 1 more pi. So since the period is 2 pi, if we shift it over 1, that gives us up to 3 pi. And now all we have to do is draw. So the standard 1, 0, negative 1, 0, 1 will work. 1 times 2 is 2. That's 2 above the midline. So we'll start here at 4. Then 0 will be on the midline. Negative 1 times 2 would be negative 2 below the midline. Then 0 once again is on and up to above the midline. Now these dots in blue, I'm going to put in a dotted line because we have not shifted it yet. Each of these points has to shift over pi radians, okay? So if we shift each of them over 2 notches, we'll be set. And I'll do this in purple here. So over 2, some of them will match up with other dots, that's okay. And now if I draw that in, we are done. Okay, so the purple one is our actual drawing. And once again, this is only one period of it. Okay, so hope you guys had a great day. If you have any questions, let me know. Get some delta math done, and definitely, as always, reach out if you have any questions.